If you have any doubts, you can ask.
Ma'am, can you explain normality?
Yeah, I will explain surely. See, okay, जब तक फातिमा join नहीं करती है, let's see what are normality. There are some topics like normality, dilution law, which we miss. Okay, inshallah, I will cover this. And yeah, one more question is this: which concentration term is temperature dependent? Right? Like temperature dependent, कौन सी concentration term होती है? Molarity, molality, mass percent, or mole fraction. Right? So you can see the molarity. Yeah. So you can see the molarity depends on volume, right? And volume changes with temperature. So that's why molarity is temperature dependent. But your molality, mass percent, and mole fraction doesn't depend on the temperature. Okay, so when this question comes, so the answer will be molarity. Molarity always depend on temperature. And yeah, one more question is there. Which one is better? Better concentration terms like molarity or molality. So what will be the answer, Aisha?
Mol-
Which one?
Molality?
Yeah, why? Reason behind that?
Because it takes like uh
It is independent of temperature. It doesn't change by
oh
with increase in temperature, right? But the molarity does. Temperature अगर increase होगा decrease होगा then your molarity changes, but your molality doesn't change because it depends on the mass of solute particles, right? Mass of solvent particles in kg, right? What is the formula for molality? Molality is the number of moles of solute divided by the mass of solvent in kg, right? So that's
yeah.
why molality is better option than that of molarity. Okay.
Okay.
And yeah, normality is just very easy. Normality is just a number of gram equivalent of solute divided by the volume of solution in liter. It is just like a molarity. It also depends on the temperature. But here, the formula of normality is number of gram equivalent of solute divided by volume of solution in liter. Now here comes a word gram equivalent. Equivalent. So what is equivalent? So equivalent is your equivalent weight. Okay. And how to calculate this equivalent weight? So it's very simple. Like equivalent weight is equals to molecular weight divided by your n factor, right? Just divide the molecular weight upon by its n factor. Now, what is n factor? So n factor is the number of ions it will give, right? Number of, for example, number of H plus ion it will give in the case of acid, for example, H2SO4, right? H2SO4 is this. So how many H plus ion it will give? It will give 2 H plus ion, right, Aisha?
Yeah.
So its N factor will be 2. So simply what you have to do, for example, you have to calculate the equivalent weight of H2SO4. So first calculate the molecular weight. Molecular weight will be 2 into 1 plus for sulfur it is 32 plus 16 into 4 and divided by its N factor. N factor is what? 2, right? So just it will give you your equivalent weight. Okay, now this you will put this equivalent weight here upon and just divide it by the volume of solution in liter. You will get the normality. I hope it is
Okay.
clear.
Yes,
And
ma'am.
its unit is normal, capital N or simple gram per equivalent. Gram per equivalent. Okay.
Okay.
Okay, we will do this in details.
Good
Then मैं
evening, ma'am. Can you repeat
good
the
evening.
topic we taught today?
Yeah. Hi Fatima. No, she had a doubt. आप जब तक ज्वाइन नहीं कर रहे थे तो उसे डाउट था नॉर्मैलिटी क्या होता है तो दैट वो मैं ले रही थी. Okay,
Okay.
we will cover that when we do the concentration terms. We will cover it in details. Okay.
Okay.
Okay, bache. So today's topic is your uncertainty in measurement. We have done, right? So today we are going to do the precision and accuracy. Do you know what is precision and accuracy? So see, precision is simply, it is the closeness of various measurements. Okay, it is the closeness of various measurements for the same quantity. But accuracy is the agreement of a particular value to the true value. Accuracy is just accurate value, which is equals to the true value. But precision is just closeness of your measurements. It's the value becomes closeness. For example, when you take, if the true value of some result is 2 gram, okay, if if in the question it is given the true value of the result is 2 gram, okay, and there are three students like your Fatima, Aisha, and the student says just like me, okay. So a student's observations are, first reading is 1.95, 1 point, it is in gram, it's also in gram, okay, so it comes to be 1.95, and second reading is 1.93. Now you can see that in these two readings, you can see there is a some closeness. 1.95 and 1.93 is very close to each other, right? And when you take average, you will get 1.940, which is not very accurate to 2 gram, which is not equals to the true value, right? So we can say that student A's reading is neither it is precise but it is not accurate. Can we say that? Because why precise? Because in precision we will just compare two readings, first reading and second reading. We will compare. If these two readings are very close to each other, then these are precision. Okay, these are precise result. But when you take average of these two readings, you will get 1.940, right? And 1.940 is not, this is not equals to the true value. What is the true value? True value is 2 gram. आपका रिजल्ट 2 ग्राम आना चाहिए. अगर accurate अगर रिजल्ट आता तो it will be 2 gram. But in this average your average reading is 1.94, which is not accurate, right? So we can conclude that student A, its result is precise, right? Precise but not accurate. But not accurate, right? Okay, let's see for the second student. Second student, first reading is 1.94 gram, and the second reading is 2.05 gram, right? Which is not quite close to each other. These two readings are not close to each other, right? There is some difference between these two readings, so we can say that these are not precise. These two readings are not precise. Okay, but when we take average, it's 1.995. Again, it is not equals to the true value, right? So we can say that for student B, the result is neither precise nor accurate, right? It's neither precise. The results, when you have to calculate the when you have to just demonstrate the precision, then you will compare the two readings, okay. But you have to, when you have to tell the accuracy, then you will see the average, okay, average measurement. So we say, we for the student B, we can say that the readings are neither precise nor accurate, right? So students A के बारे में आप क्या बोलोगे? देखो readings, see the readings. First reading is 2.01, okay, and second reading is 1.99. So it's quite close to each other. These two readings are quite close. So we can say that these students see these readings are precise. Okay, why it is precise? Because these readings are quite close to each other, 2.01 and 1.99. Okay, there's a difference of 0 0.2 only, right? So here you can see that 2 gram. When you take average of these two readings, you will get exact 2 gram. And this is just equal to the true value. This is equals to the true value, which is 2 gram. So we can say that student C reading is precise as well as accurate. accurate. Clear? So
Yes.
that's the meaning of accuracy and precision. Then you can note down.
Ma'am, can you show the definition of accurate and precise?
Yeah. Just wrote down. Aisha, I remember one question has come from this topic in your exam also, right? So have you done it correctly? Like precision and accuracy, have you done correctly? Aisha, are you there? Done?
Yes, ma'am.
Ma'am, were you calling me?
Yeah.
I
I
had
said that.
messaged you. I was praying.
What happened?
I had messaged you. I was praying.
Okay, no problem.
Ma'am, what were you saying?
I just said that one question has come from this topic in your exam also. Have you done it properly?
Which one, ma'am?
Precision and accuracy, the one which
Yeah,
this
yeah,
type
yeah.
of
Ma'am,
question. Same question was there, but the
almost.
numbers, yeah, numbers were different. Okay, so let's see the addition and subtraction of significant figures. How to add and subtract those significant figures. Okay, so we will take some examples. Okay, for example, if there are some numbers, for example, 12.011, 12.01, just wrote. Okay, this is the first number, right? Second number is 13.0. Third number is 1.012. So we have to add these numbers. Okay, so what will be the 2, 2, 6, 1, 2, 3. Okay, so this is the result. But after decimal, we have to put just minimum number of digits. Okay, in the final answer, you just have to write only one digit after decimal. This is the standard form. Okay, just remember you have to just put only one digit after the decimal. Means only this is 31.1. Like this, you have to write. It's very easy. Okay, multiplication and division of significant figures. So, for example, I will give only one examples because these are not very much important. Like 2.5 into 1.25. Okay, first multiply these numbers. So you will get 3.125. Okay, but the final answer you have to check. You have to check in these two numbers, what is the minimum number of digits after the decimal? So in this first number, the after the digit, there is only one digit, right? Only one digit after the decimal, right? But in this, after the decimal, there are two digits. Okay, so we will choose minimum. Okay, we will in the final answer, you will write only the minimum number of digits after the decimal, which is 3.1. This is your final answer. Okay, okay, write it down.
Ma'am, can you scroll up?
Yeah, I think we don't have much time. Fatma, your exam is on 14th?
11.
Oh, 11th. Today is 8. Only, okay. Only this chapter is coming.
Ma'am, till limiting reagent.
Okay, done.
Done, ma'am.
Okay. Okay, next, see, while if you have to limit the result to the required number of significant figures, okay, if you have to limit the result to a required, if there is in a question, you have just it is given that, for example, it's given that find the answer till the two significant figures or three significant figures. Okay, so what we will do? Let's see. So there are some rules we should keep in mind. For example, first rule is this: if the rightmost digit to be removed is more than 5, okay, if we have to remove the rightmost digit. What is the rightmost? Means decimal k right. Okay, decimal's rightmost digit is to be removed if the digit is more than 5. If the digit we have to remove is more than 5, then the preceding number is increased by 1. It's very simple. For example, if 1.386, okay, and we have to just, we will see the terminal end. Okay, we will see the terminal end digit. So it is 6, and 6 is more than 5. 6 is more than 5, right? So this preceding digit of 6, it is increased by plus 1. Okay, so your final answer will be 1.39. This will be your final answer. Got it? What I said, if the rightmost digit to be removed is more than 5, okay, then the preceding number is increased by 1. So, for example, in this is 6, right? This is the term and the rightmost end digit. We will see the end digit, the terminal end digit. So it is more than 5. So if it is more than 5, then this preceding digit is increased by plus 1. Okay, and you will just remove this digit, 6 digit, and plus 1 will be added up in this 8. Clear? Clear? Both of you, Aisha and Fatima?
Yeah, ma'am.
Okay.
Yes, ma'am.
Second is, if the rightmost digit is a digit to be removed is less than 5. If the digit is less than 5, for example, same example we will take 1.384. Okay, so we will see the terminal end digit. So this is 4, which is less than 5. So there will be no change in the preceding digit. So 1.38 answer. Clear? So we will not add 1 plus 1 in the preceding digit, which is 8. Okay, just remove this digit 4 and just write down 1.38. This is your final answer. Example, again, second example, 4.334. Okay, Fatima, you will tell me the final answer. 4.334. Simply it's just a round up.
4.33.
Yes, good. 4.33. ओके, जूनियर क्लास में हम देखते थे ना, राउंड अप हम करते थे, राउंड ऑफ मैथमेटिक्स में. So that's okay. So third is, if the rightmost digit is 5, rightmost digit is not more than 5, just it is just a 5. So what will be it? Then we have to check the preceding number of 5. In that case, if the rightmost digit is exact 5, in that case we have to check the preceding number of 5. Okay. See, Fatma, बच्चे concentrate over here. Concentrate here. Okay, so I said that if the rightmost digit is 5, so if we have to check the preceding number of 5 in that. And if the preceding number is even, then there will be no change. For example, 6.25, right? So this is the number rightmost digit is 5. So in this case, we have to check the preceding digit of 5, which is 2 over here. And 2 is even number. 2 is even number. So if the number preceding the 5 is even, then there will be no change. Then there will be no change. So your final answer will be 6.2 only. 6.2, this is your answer. Clear? Second rule in this is, if, for example, it is 6.35. Okay. So in this case, you have to check the preceding number of 5, and the preceding number is odd number. This is odd number, right? So if there is the preceding number of 5 is odd, then just increase, the preceding number is increased by 1, right? Means you just have to add plus 1 in the preceding number of 5, and your final answer will be 6.4. 6.4. This is your final. Clear? Clear or not, Fatima?
Yes, ma'am.
Okay, just write down.
Ma'am, can you show from the beginning?
Yeah. Yeah, Aisha. Aisha, are you there?
Yeah, ma'am. Sorry, I was reading.
Okay, I didn't get your homework. After the class, daily I have given you homework, but you didn't submit. Why? Can I know the reason?
I'll submit it today.
But आप daily मैं daily 3 to 4 questions दूंगी, not more than that, okay? Daily basis पे आप करो ना, मैं टॉपिक से रिलेटेड ही क्वेश्चन दूंगी.
Okay, ma'am.
आप डेली करोगे तो आपका जो भी टॉपिक होगा वो क्लियर होता जाएगा, राइट? और आप लास्ट में रखोगे, पेंडिंग वर्क रखोगे, तो वो आप बस जल्दी जल्दी एज इट इज फॉर्मेलिटी के लिए करोगे और सबमिट कर दोगे. उससे मुझे कोई फायदा नहीं होगा, आपका ही लॉस होगा, राइट आयशा?
Yeah.
मैं जो भी क्वेश्चन देती हूँ आफ्टर द क्लास, आई नीड इट इन द नेक्स्ट डे, okay? Before the next class I need that homework so that we will discuss in the class, okay?
Okay, ma'am.
जो भी डाउट हो आपको क्वेश्चन से रिलेटेड, टॉपिक से रिलेटेड, सो दैट यू कैन आस्क मी. तभी तो आपके डाउट्स नहीं होते आप लोगों के, आप होमवर्क ही नहीं करते. प्लीज डू इट बच्चे. आपका तो ये
Okay.
रिवीजन क्लास हो रहा है, आपका फर्स्ट चैप्टर तो और अच्छे से क्लियर हो जाना चाहिए. कुछ कुछ टॉपिक्स मिस हुए हैं, आई विल क्लियर दैट, ओके? मैं डिटेल से उसे कवर करूंगी इंशाल्लाह. बट एटलीस्ट जो एनसीईआरटी के बैक क्वेश्चंस हैं, एनटेक्स क्वेश्चंस है, डू दैट बिकॉज योर चैप्टर्स आर कंप्लीटेड फ्रॉम माय साइड.
Okay, ma'am.
Yeah, बच्चे, please do that. NCERT back questions, each and every question, just do that. There are 36 questions, I think, in the first chapter, and in-text questions are like 7 to 8 in-text questions. So do each and every question, and if there is any doubt, please ask me. That, ma'am, this question समझ नहीं आया, please explain it. Okay,
Yeah, ma'am.
I'm there for you to help you. Okay. And you, Fatima, also. Okay, after the exam, जो भी मैं अब अब दूंगी होमवर्क, जो भी दूंगी, I need submit it by that only. Submit it
My
before the
unit
next
test is
class.
going on. That's why I couldn't submit.
Okay, after your exams. Okay?
Okay. After Sunday, I'll submit.
Yeah, yeah, bachcha. Okay, noted?
Yes. The third one.
Okay, we'll do that.
But what is it return if one number is odd?
Yes. If one number is odd, third one, right?
Yes.
If one number is odd, you have to just check the last digit. Last digit. For example, if there is a number 1.634 7 and 5, this long number. Okay, so for the third rule, just check the last. Always check the last digit. It is 5. Okay, so if there is a 5, then you have to check the preceding digit of 5. Okay, the preceding digit, just a prefix.
Ma'am, I was asking what's written after the arrow.
Okay, add on. Just write down the this answer. Can you repeat the question in
Ma'am, I
details?
was asking what is written after the arrow. If number is odd after the arrow.
Okay, okay. Number, this is increased. This is increased. Increased by 1. Okay. We can sometimes write increase for this symbol for increase and this symbol for decrease. Okay. But in your exam, don't do that. I'm using shortcut over here.
Done, ma'am.
Okay. Okay, now here's a term, dimensional analysis. Okay, so dimensional analysis means, so in calculations, there is a need to convert units from one system to another system, right? So the method which is used to accomplish this is known as, Fatima, बच्चे concentrate over here.
Yes.
So dimensional analysis is, in calculation, we need to convert one unit from to the another unit, right? So this method is used to accomplish this, right? Means this method is dimensional analysis is used to convert one unit to another unit, and this is also called as factor level method. Factor level method or unit factor method. Unit factor method, because we are converting unit. Okay. For example, we will discuss it by examples like how many, first question is how many seconds are there in 2 days? Okay. So in the one series, how you can do this question? Yeah, by a unit factor method. For example, unit factor method, it is used in which we multiplied in series in one step, right? For example, let's see. So this is 2 days, 2 days. So first try to just convert it into the hours. After hours, convert it into the minutes, and after minutes, just seconds. Okay. So 2 days. So in one day, how many hours are there? 24 hours. Now see, this is a method in which we use the series method. सीरीज में एक ही स्टेप में हम ये क्वेश्चंस करते हैं, right? So this 2 days, so make sure in multiply, when you do multiply, so make sure to write the this unit, जो यहाँ पे unit होगा, days unit, so just write it in the denominator. Why in the denominator? So that it will be cancel out. ओके ये डिनोमिनेटर में होगा तो ये डेज और डेज ही कैंसिल आउट हो जाएंगे, राइट? सो 1 days is equal to 24 hours, and after 24 hours 1 hour is equals to 60 minutes, right? And in 1 minute there are 60 seconds. I hope it is clear why I'm doing so, because days it will be cancel out, hours cancel out, minutes cancel out, and you will get the answer in second. Clear? So तो ये हम इस टाइप से करते हैं, मल्टीप्लाई करते हैं हम सीरीज में एक ही स्टेप, राइट? सो दिस इज अ, so 2 into 24 into 60 into 60 seconds you will get. Means when you multiply, you will get 172,800 seconds. Clear? So that's how we do the conversion in the one step. Okay, single step method.
Ma'am, like these questions they will ask.
Yeah, sometimes they ask because it is given in NCRT. Sometimes they can ask in fill in the blanks type. Like this question. This is the question from NCRT. Just write down, then we will discuss that. Aisha, do this question, bache, and tell me the answer. In 1 kilometer, how many millimeters are there and how many picometers are there? Just do it and tell me the answer.
Okay, ma'am.
Okay. Now we will see this question.
Ma'am, is it 10 raised to minus 3 mm?
Mom,
Mm,
10 raised to
mm,
6 mm.
10 raised to the power. And for Aisha, your
1000 into
answer
10 raised to minus 3.
1000 into 10 raised to the power minus 3. Okay, let's see. No, I don't think. 1 kilometer into,
Power 10 raised to the power 6.
yes, 10 raised to the power 6 will be your answer. See, Fatima, how? So in 1 kilometer, how many meters are there? 1000 meter.
Yes.
Okay. And in 1 meter, how many centimeters are there? 100 centimeter.
100 cent.
Yeah. And in 1 centimeter, how many millimeters are there? 10 millimeters. Okay. So just you will get all these units will be cancelled out. And you will get the answer 10 raised to the power 1, 2, 3, 4, 5, and 6. 10 raised to the power 6 millimeters.
Ma'am, why don't we use the table like you have given for pico, mega, and that also the value is given, right?
Yeah, but you don't have to calculate just directly. You will use this factor method, unit factor method, this series method. And we will
Because in
also
school,
use that,
ma'am has
that,
used that.
yeah, we will also use that picometer. That table also we will use. But in that case also you will get 10 to the power 6. Milli means you will get 10 to the power 6 over here. Okay, second question. And how many, in 1 kilometer, how many picometers are there? Just calculate it in 1 kilometer into, in 1 kilometer, 1000 meter, right? And in 1 picometer, how many meters are there? 10 to the power minus 12 meter. Clear?
Yes.
I told you this unit, this is here, meter is there. So we have to write meter over here. Why? Because this will cancel out. Okay, and you will get kilometer and 1 kilometer. This will cancel out. 1 meter, meter will cancel out, and you will get 10 to the power 3 divided by 10 to the power minus 12 picometer. Right? It means 10 to the power 3, and this will give you 10 to the power minus. Okay,
10 raised to 15.
yeah, this will be your final answer. Clear? So you should know what is picometer. How many meters are there in picometer? Okay, so you should remember that table.
Then, ma'am,
Okay. If done, then do this. Tell me how many liters are there in 1 milliliters.
liter or milliliter?
How many liters are there in 1 milliliter?
Okay.
Okay.
Ma'am, can you repeat that equation that you had given for one centimeter cube and decimeter
One-
cube relation?
Okay, okay. Yeah, yeah. See, both of you first see here. First see here. See, so you have to just 1 meter, 1 milliliter is equals to how many decimeter cube? So first we will know 1 decimeter cube is equals to how many centimeter cube, right? So see, in 1 decimeter cube, there are 10 to the power 3 centimeter cube, right? Let's see how. See, in 1 decimeter, we know 10 centimeter is there. In decimeter, 10 centimeter is there, right? So in 1 decimeter, so in 1 decimeter is equal to 10 to, just a second. Yeah. So if just cube, when we take cube both sides, so what will be it? 10 to the power 3 centimeter cube, right? So 1 decimeter cube is equals to 10 to the power 3 centimeter cube. Just remember this relationship between decimeter cube and centimeter. Okay. Okay, let's see the solution first. We know that 1 milliliter into, okay, so milliliter we will write in the denominator. So in 1 liter, how many milliliters are there? 1000 milliliters. Okay, so and just calculate it. So you will get 10 to the power minus 3 liter. In 1 milliliter, how many liters there? 10 to the power minus 3. Okay, this milliliter and milliliter will cancel out and you will get the value in liter. So 10 to 1 upon 10,000, which means 10 to the power minus 3. Okay, now see, in 1 milliliter, and yeah, 1 milliliter is equals to 1 centimeter cube. 1 milliliter equals to 1 centimeter cube. Just remember that. In 1 milliliter, how many centimeter cubes are there? 1 centimeter cube. Okay, so we can take 1 milliliter as 1 centimeter cube also. So 1 centimeter cube into, now we will use this relationship between decimeter cube and centimeter cube. And in 1 decimeter cube, how many centimeter cubes are there? 10 to the power 3 centimeter cube. Okay, so this centimeter cube and centimeter cube cancel out and you will get 10 to the power minus 3 decimeter cube. Right? So we just substitute this 1 milliliter to 1 centimeter cube because in 1 milliliter is equals to 1 centimeter cube. Right? So you can substitute this value. Okay, so you will get 10 per meter. This will be your answer. I hope it is clear. Now you can do the conversion.
Ma'am, can you explain this again?
Yeah, both in 1 milliliter, both here or only decimeter part.
The decimeter part.
Okay, I said that here it is given in 1 milliliter is equals to how many decimeter cube, right? And we know that 1 milliliter is equals to 1 centimeter, right? 1 milliliter is also always equals to 1 centimeter cube. Just remember that. Okay, so we can substitute 1 milliliter. For example, we will write 1 milliliter into this, right? But we will, okay. So we will write uh, 1 centimeter cube instead of this 1 milliliter. Why? Because 1 milliliter is equals to 1 centimeter cube. We can substitute the value. Okay, we can substitute. Why? Because 1 milliliter is equals to 1 centimeter cube. So in 1 centimeter cube into, because we know that there is a relationship between decimeter cube and centimeter cube. That's why we are substituting the milliliter to centimeter. Okay. Now we know that in 1 decimeter cube, how many centimeter cubes are there? 10 to the power 3 centimeter cube. Okay, I just explained here. Why? Because why we are writing a centimeter cube in the denominator? Why? Because we have to just cancel these units. Okay, and we just have to write the final answer in decimeter cube. We have to convert milliliter into decimeter cube. That's why we are writing over here. Now, 1 decimeter cube upon 10 to the power 3. 10 to the power 3 means 10 to the power minus 3. You will get the answer. Okay, we can substitute this value. 1 milliliter is equals to 1 centimeter cube. Okay, this is the NCRT question.
Okay.
If done, if done, just write down the question. This is your homework. This is your homework. In 1 milligram, how many kgs are there and how many nanograms are there?
Can you scroll up?
Yeah.
Ma'am, you can scroll.
Okay, write down this question.
Ma'am, nanogram is 10 raised to 9.
And to the power minus 5. Okay, that's your homework. No need to do it right now. Okay. So now here's a topic which is law of chemical combinations. Okay. So we know that chemistry usually involves chemical reactions, right? And in chemical reactions, two or more elements combine to produce a single compound, right? So the reactions which involves this combinations of various elements, right, where the various elements combines to form a single compound. So these reactions are governed by these 5 laws. Okay, these 5 laws are very very important laws in in combining the whenever there is a reaction, chemical reactions occur, then these laws are very very important. Okay, so first law is law of conservation of mass, right? We will discuss one by one what are these laws and what are their and we will take examples also. Second is law of definite proportion. Third one is law of multiple proportions. Fourth, Gay-Lussac's law, and the fifth one is the Avogadro law. Okay, so let's understand what these 5 laws want to tell us. Okay, let's see what are those statements which are given by the scientists. Okay, so first law is law of conservation of mass, right? And this law is proposed by Antony Lavoisier in 1789. Okay, which year 1789. And yeah, according to this law, mass can neither be created and nor it can be destroyed. Okay, it can only be transferred from one form to another. Okay, like see, it means this statement means total mass of the product obtained by chemical combination is equal to the sum of mass of all the reactants involved. Okay, means the mass of product is equals to always equals to the sum of mass of all the reactants. Okay, the mass is neither creating and nor it is destroying. Okay, for example, calcium carbonate, CaCO3. Calcium, when you calcium carbonate is formed by the reaction of calcium oxide and calcium dioxide. Okay, this is calcium dioxide and calcium oxide. When they combine, it forms calcium carbonate. Okay, so for example, see, calcium carbonate is, for example, 10 grams. Okay, so the calcium oxide is, for example, 5.6 gram and this is 4.4 gram. So the total mass of reactant will be equal to the total mass of product, right? So here reactant is only one reactant, calcium carbonate. यहाँ पे calcium carbonate का dissociation हो रहा है, right? When you give heat, then it will dissociate to form calcium oxide and calcium dioxide, right? So these two are products. These two are products, and this is the reactant. Calcium carbonate is reactant over here. Okay. Yeah, similarly, we can say that calcium oxide plus calcium dioxide, it combines to form calcium carbonate. Right? So in this case, these are reactants and this is product. Okay. But in each and every case, according to this law, the total mass of product will be equal to the total mass of reactants involved. Okay. So this 10 gram, this is the reactant. So mass of reactant, which is mass of calcium carbonate is 10, right? And the mass of calcium oxide is 5.6 and for calcium dioxide is 4.4. So when you add, you will get 10. So you can see that the mass of product and reactants are equal. Means my mass is neither be created nor be destroyed. Okay, mass is just it is transformed from one form to another. So this is the law of conservation of mass. Mass is conserved. Clear? Any doubt in this?
Yeah, ma'am.
Oh,
Ma'am, should I write this?
yeah. This side. Or you can take a screenshot because we have very less time. Only half an hour left. We have to cover this law of chemical combination plus the Dalton's atomic theory in today's session.
Ma'am, I took a screenshot.
Okay. After the class, you can write. Okay. So second law is law of definite proportion. Now see what is law of definite proportion. So it is the law which is proposed by Joseph Prost. Okay. साइंटिस्ट का नाम आपको याद रखना है जोसेफ प्रॉस 1799 में इन्होंने ये लॉ दिया. Okay. Now, according to this law, elements are always combined in a specific proportions only. Elements will combine in a specific proportions only. Means elements always combine in a specific ratio, irrespective of the number of how many number of reactants are there, right? It doesn't depend on the number of reactants. It depends. It only give you the specific ratio. Let's see. Let's see by doing some example. For example, ethyl alcohol. Ethyl alcohol. What is the formula for ethyl alcohol, Fatima?
CH,
Ethyl,
CH2H.
yes. Okay, so we can write C2H5OH. C2H5OH. This is ethyl alcohol is nothing but a ethanol. It's ethanol, right? Ethyl alcohol or ethanol both are same. So here you can see that the carbon consistent. It is the ethyl alcohol is formed by the combination of how much carbon? So 52% carbon oxygen 35%, and hydrogen 13% by weight. Now see how. So you can see that in C2H5OH. So first calculate the molar mass. What is the molar mass? 12 into 2 plus 6 plus 16. 12. Why 12? 12 for carbon and 2 atoms of carbon. Okay. And 6 hydrogen. 5 plus 1, 6 hydrogens are there. Add into 1. Plus, how many oxygens? Only 1 oxygen. So 16 for oxygen. 12 plus 2. 12 into 2. 24 plus 6 plus 16.
Neat.
So it will give you 46.
30, 30. 30 plus 16.
36 plus, okay, 30 plus 16, you will get 46 over here. 46 gram per mole. Okay. Now you can see that if I tell you to just calculate the element, each and every element composition. So how will you calculate? So how many carbons are there? Aisha, tell me how many carbons are there? 2 carbons. Okay, so what is the mass for 2 carbon?
12 into 2, 24.
Yes. So we are calculating the mass percent of carbon. Okay, so 12 into 2, 24, 24 divided by 46 into 100. Right? This is why 24. 24 is C2. How many carbons are present? 2 carbons. And for 2 carbons, what is the weight? What is the mass? 12 into 2. Right? 12 into 2, this is 24 divided by the total mass. Total molar mass, which is 46 into 100. Why? Because it is a mass percent. Okay, calculate it. And you will get the
Ma'am,
value. Yeah,
I don't understand, like, how do you shift these values to that side and you get the mass of carbon?
that's this value came. How it came, I just explain you. I explain you how these values came. This is given in NCRT 92, 52%, 35%, and 13%. And how these values
That,
come, I will explain you. I am
like,
just
how, like, what is the formula for, is it like a specific formula for getting the mass? Like that I'm
yeah,
asking.
mass percent. We will do it in the concentration terms. Okay, concentration terms हमने अभी पढ़ा नहीं है. Mass percent. See, the mass percent formula is the mass of that component. Mass of that component divided by the total mass of all the component, right? Total mass of this compound, or you can say all the component into 100. This is the formula for mass percent. Okay, so that's how we are calculating the mass of component first. So we are calculating for carbon, right? So how many carbons are there? 2. So 12 into 2 divided by the total mass. Total mass is 46, right? Into 100. So you can 2 ones are 2, 2 twos are 4, and 2 twos are 4, 2 3. And when you calculate this, you will get something like 52.17%, right? So you can just take the approximate value to 52% only. So that's how this carbon composition came, right? 52%. That's how it came. You can similarly calculate the mass percent for oxygen and hydrogen as well. You will get the same value, 35% and 13%. Here, yeah. So you can see that from this example, you can see that the total amount of ethyl alcohol which is present, total amount. So here you can see that the carbon is present. This compound consists of 52% carbon. Ethyl alcohol, we can say that now, that ethyl alcohol consists of 52% carbon and 35% oxygen and 13% hydrogen, right? So this is according to the law of constant proportion, means the element proportion is constant. It will not change, right? In ethyl alcohol, it is always fixed that carbon will be present in 52% always. Okay, and hydrogen will present in 13% and oxygen 35%. So this is the law of definite proportion. Means the proportion is constant. It will not depends on the number of reactants taken. It will give you a specific ratio. Okay, means the elements are always combined in a specific ratio, specific definite proportions only. I hope it is clear now. Okay, just take the screenshot.
Done.
Okay, the third law is law of multiple proportion. Okay, so the law of multiple proportion is proposed by John Dalton in 1804. Okay, so according to this law, whenever the same two elements combine, means whenever the same two elements combine to form more than one compound. Okay, when the two elements combine to form more than one compound, then various masses of an individual element that combine with the same mass of the other element exist in the ratio of a small whole number. So let's see what does it mean. So let's consider some example. So for example, consider carbon and oxygen. Carbon and oxygen atoms. Okay. So carbon and oxygen combine to give two different carbon plus O2. When it combines, it can give carbon monoxide plus carbon dioxide also, right? Carbon monoxide and carbon dioxide. So in carbon monoxide, the amount of oxygen present for one carbon atom is 12 gram. We can say that one oxygen atom gives 1 gram of carbon. So 16 gram of oxygen will give 12 gram of carbon. Can we say that in carbon monoxide? See, in carbon monoxide, what I said is 12 gram, 12 gram of carbon plus 16 gram of oxygen is there, right? But in carbon dioxide, 12 gram of carbon is there, but there are 32 gram of oxygen. Okay, and you can see that in both the ratio of amount of carbon present in the carbon monoxide and the carbon dioxide will give you the simplest whole number ratio. Okay, so see, if we take ratio of these two and these two, so it will give you 1:1 here, and in this case you will get, for example, if I'm taking the ratio of CO2, just a second, mass of oxygen if I'm taking. So it will give you 32 is to 16, which means 16 ones are 16, 16 twos are 32. So it means 2 is to 1. So it will always give the simplest whole number ratio, right? So law of multiple proportion says when the two elements combine to form more than one compound, then the various masses of an individual, see the various masses of individual. So here in the case of carbon and oxygen, mass that combine with the same mass of other elements will give you a simple whole number ratio. Okay, it will always give the simple whole number ratio. That is the law of multiple proportions. Why multiple? Because two elements combine to form more than one compound. And when you take the ratio of that compound, you will get a simplest whole number ratio. Yeah, next law is Gale-Lussac's law of gaseous volume. So in this case, Gale-Lussac talked about the volume, gaseous volumes. And this law was proposed by Gale-Lussac, as the name suggests, and in which year? In 1808. Okay, so this law is just similar to that of the third law, which is law of multiple proportion. Okay, very much similar. So this law says that the ratio of the volume of all the gaseous reactants and products can be represented in a small whole numbers. Okay, so in this case, we will talk about the ratio of volume, because we are talking about the gas, right? So what it says, this law says the ratio, when you take the ratio of volumes of all the gaseous reactants and products, so it will give you a small whole number ratio. Okay, so and when gases react at a particular pressure and temperature, The ratio of volume of reactants and products can easily be expressed in a small whole number ratio. For example, if we combine the hydrogen gas and chlorine gas, okay, so it is governed by a Gay-Lussac's law, like how when H2 gas and Cl2 gas is combining, it will produce HCl, hydrochloric HCl gas. Okay, so in this example, you can see that what is the coefficient over here? Coefficient is 1, here also 1, and here 2, right? So we can say that one volume of hydrogen gas, it is combining with one volume of chlorine gas to form two volume of HCl gas. Can we say that? Can we say that one volume of H2 gas, it is combined with one volume of Cl2 gas to produce two volume of HCl gas, right? So in this case, when you take the ratio of volume of all the reactants and products, you will get 1 is to 1 is to 2. And this will give you the simplest whole number ratio. I hope it is clear. 1 hydrogen H2 is present, 1 Cl2 and 2 HCl. Clear? So the volume, it will give the simplest whole number ratio of volume. Clear or not? Both of you.
Yes,
Clear?
ma'am.
Yes.
Yeah. Okay, let's see the next law. A screenshot take it.
Ma'am, can you show the law before this?
This law?
Ma'am, the third one, multiple proportion.
Yeah, this law.
Done, ma'am.
This also done?
Yes, ma'am.
Okay. Yeah, the fifth law. The fifth law is again very important. It is Avogadro's law of chemical combination. Right. So it is proposed by Avogadro in 1811. And according to this law, at a particular, at a given constant, and yeah, remember in this case, this Avogadro, the scientist, took constant temperature and pressure. Temperature and pressure are constant over here. So at a given constant temperature and pressure, the volume of gaseous molecules is directly proportional to the number of moles. Okay, now we know that what is ideal gas equation. You all have heard about this ideal gas equation. Yes or not? Remember what is ideal gas equation? Asha and Fatima,
Yes, ma'am.
what is ideal gas equation? It's
Uh,
Q, it's PV equals to nRT, right? PV equals to nRT. So P is pressure over here, pressure, volume, number of moles, R is gas constant, and T is your temperature, right? So this scientist, what he did, he just constant this temperature and pressure are constant over here, right? So pressure and temperature are constant. And we know that R is also a constant. R is a constant because it is the gas constant. Like it is constant again. So if we take a pressure, temperature, and this gas constant, then this volume is directly proportional to the number of. Okay, so this law says that the volume, when you constant the temperature and pressure, then the volume is directly proportional to the number of moles. Okay, so what is V over here? So where V is volume of gaseous molecules. Gaseous molecules, right? And the total, N is the total number of moles, number of moles of the gas. Clear? So according to this law, the volume of gaseous molecules is directly proportional to the total number of moles of the gas. Okay. So if we remove this proportionality sign, this directly proportional sign, so here we will take k into n. Whenever we remove the constant proportionality sign, then there comes a constant symbol, right? Constant. Now, what is k over here? So k is proportionality constant, where k is proportionality constant. Okay, and so from here you can write v upon n is equals to k. Can you write? And k is constant. V upon n. V just put just move this number of moles to over here, right? So you will get k is equals to v upon n. Okay, now if we talk about this, if there are two gases, if there are two gases, so can we say that v1 upon n1 is equals to v2 upon n2, right? So if there are two gases, then v1 upon n1 equals to v2 upon n2. And now what is v1 and v2 and what are n1 and n2? Where v1 is volume of one gas, volume of one gas, and one is number of moles of one gas, first gas you can say. V2 is volume of another gas, volume of another gas, and N2 is the number of moles of another gas, number of moles of another gas, another gas. Just remember this relation. Okay, when sometimes they ask you this type of question, they will provide you the volume and the number of moles of one gas, right? And the only, for example, only volume of another gas or only the number of moles for another gas, and they will ask you what is the volume of second gas. Okay, so these four इन फोर में से आपको कोई भी तीन तीन चीजें क्वेश्चन में प्रोवाइड की जाएगी एंड फोर्थ वन दे कैन आस्क in the question. Okay, so sometimes this type of question came. So you should remember this formula v1 upon n1 equals to v2 upon n2. And how it came? So it came from the ideal gas equation PV equals to nRT by putting the temperature and pressure constant. Okay, so what does this law say? So Avogadro law says that when you put the temperature and pressure constant, then the volume of gaseous molecules is directly proportional to the number of moles. Okay, means when you increase the number of moles, then the volume will also automatically increase, and vice versa.
Ma'am, can you show the fifth law? Ma'am, can you scroll down?
Hmm. Done?
Yes, ma'am.
Okay, so the last topic, which is Dalton's atomic theory for today's class. So Dalton's atomic theory. So Dalton's this scientist, he observed the laws of chemical combination, right? So the laws of chemical combination he observed, and he proposed some atomic theory of matter, right? From based on that chemical law of chemical combination, based on those five laws, he just proposed atomic theory, which is known as Dalton's atomic theory. And in which year he proposed? In 1808. Okay, so Dalton's atomic theory was proposed by Dalton Sahab in 1808. Okay, and the main points of Dalton's atomic theory are as follows. So he gave some points. The main points of Dalton's atomic theory. So what are those points? So first point, he said that matter is made up of extremely small indivisible particles, which are known as atoms. Okay, so he said that matter, sometimes in your exam directly question came from here that explain the Dalton's atomic theory, and just write down the postulates, various postulates of Dalton's atomic theory. Okay, the postulates is nothing but these main points. And sometimes they ask you the limitations. What are the limitations? What are the demerits of Dalton's atomic theory? Okay, so matter, he said that matter is made up of extremely small indivisible particles, which are known as atoms, right? Second point, he said that atom of same substances, atom of same substances are identical in all respects, right? In all respect means they possess same size, same shape, same mass, and same chemical properties. Okay, you can write in bracket means they possess same size, shape, mass, and chemical properties, etc. So according to him, all the atoms of same substances are identical in all respects, means they all have same size, same shape, mass, and chemical properties. That's it. Okay, so third main points of Dalton's theory was atoms of different atoms of different substances are different. Different substances are different in all respect. In all respect. Okay, in all respect means just similar to that. They possess means they possess different shape, size, mass, etc. Okay, fourth point was that atom is the smallest particle that takes part in a chemical reaction. Okay, he also mentioned that atom is the smallest particle that takes part in chemical reactions. Okay, this was the fourth point. Fifth point, he said that fifth postulate is that atoms of different elements may combine with each other in a fixed, simple whole number ratio to form compound elements. Okay, he said that atom of different elements may combine, they may combine with each other in a fixed, simple whole number ratio to form compound, to form compound. Okay. Okay. Sixth was that atom can neither be created nor be destroyed. Atoms can neither be created. Which law was it was?
The first law.
Yeah. What was the name of the first law, Fatima?
Law of conservation of mass.
Yes, good. Atom can neither be created nor be destroyed. Means the atoms are indestructible. Okay, you can't destroy the atom. Okay, written. So these are the main postulates of Dalton's atomic theory. And he gave these postulates by observing those those five laws of chemical combination. Okay, so these are main postulates. Sometimes they ask in your exam, just write down the postulates of Dalton's atomic theory. So you should write all these points. Okay, okay. So I think the time is up. We will discuss the limitations of this Dalton's theory in the next one. Okay. Is there any doubt? Any doubt from today's class? You can ask. Everything is clear? Aisha and Fatima.
Yes,
Yeah,